Welcome back. Today we're going to look at declaring arrays. So an array is a type of variable that allows you to store multiple elements within one variable. And its syntax is as follows. You put the data type, the name of the array, and within square brackets you identify the number of elements you're going to put in this array. So the data type can be float, int, double. It can be any type you want. And the array name is just like any other variable identifier. And the size is an integer that represents how many variables are in the array. So for example, if we wanted to have an array to store the number of bills, we would make bills in over a year, and perhaps we would make a float array, since bills would be you would need a decimal result. And in this case, if we want one per month, we would have the number 12 as the size of our array. So let's give that a try. Pause the video and write down what you would do to declare a 15-element array of doubles called student grades, and then hit continue when you're done. So first we want to write the type. And so in this case, the type would be doubles. And we want the name, so student grades. And let's see, we want 15 elements. So that would be our declaration statement for student grades. Let's look at this example here where we have our array of bills. So in main, we're declaring this float array of bills. And what that will look like in memory is, floats take 4 bytes of memory. So, given the location where this array starts, which, just notionally we could say it was at this memory address, every subsequent element will be 4 bytes off from the previous element. And we have an indexing method with, or each element in an array has an index. And the index doesn't start with 1, it starts with 0. So the 0th element in the bills array will be located here. Then we have the next one, then the next one, and so on. Notice that because arrays are 0 indexed, the array starts with element 0, not 1. And that means that the last element is actually the size of the array minus 1. So it goes from 0 to 11 and not from 1 to 12. The other aspect of arrays is that all the elements in an array are stored in contiguous elements in memory. So they're one right after the other. It's possible to make arrays in C++ of any data type or class. So you could make an int, a double, a string, a char, anything you wanted. Note that arrays in C++ are all 0 indexed, so the first element is always 0. The for loop that we learned is actually very well suited to allowing us to traverse an array. So let's say we wanted to go through the bills that we created and ask the user to input a value for them. Well, we could do it with this piece of code here. So here, notice that we have a for loop. It starts at index 0, and it will continue for while I is less than the size of this array. There's 12 elements in the bills array, so we're going to go till I is less than 12. And the reason we're going to less than 12 is because the last index is 11. So if we went to 12, we would go off the end of the array. So we don't want less than or equal, we want less than 12. And then, we'll plus I to iterate through the next one. So the for loop was made specifically to navigate arrays very well. And in this case, we'll ask the user to enter, a bill. Now, notice that we are displaying I plus 1 to the user. And the reason is that if you ask the user to enter a bill for month 0, they're probably going to be a little confused. So often what we're going to be doing is we're going to be adding 1 to the index number when we're displaying it to the user. And then if the user ever enters an index number, you would be subtracting 1. But in this case, you're just asking them to enter the bill. So we'll just insert it at I, which will be 1 less than the one that they told them. And so we'll fix the 0 indexing. So you're constantly doing this adding and subtracting one thing whenever you're dealing with arrays and a user. So we'll start off with I is equal to 0. We'll see out. Notice it says enter the bill for month 1 because 0 plus 1 is 1. Then we get the user's input. Let's say they put 45.14. That will assign it into bill's index 0, which is down here. And then we go back through and increment I. Again, I plus 1 is now 2, so it says enter bill for month 2. Let's say they enter the same number. That's going to go into bills at index I, which is 1, which is this one right here. And then we go to the next I. And we'll continue on at getting inputs from the user, putting it in the right location, and just looping through. Once we're done, we will have all the elements loaded in our array. So now we want to use that array. We want to get elements out of the array. The way we can do that, and let's say we want to sum all of these up. This is a very important pattern. It's the accumulation pattern. And the way you do accumulation is you set up some variable that you're going to start off at some starting value, typically 0. You're going to loop through your collection, the array in this case. And then what you're going to do is you're going to add whatever's in that array to what's currently in your accumulation variable, and then assign that total back into the accumulation variable. And so this way, every time you add a bill, it'll add it back into itself, and so you'll get the total. Now in this case, we're going to want to return an average, so we will take that sum and divide by the number of elements to get the average. But to get the sum, we have to do this accumulation. So accumulation again is start with the 0, add the current sum to each bill, one after the other, and eventually the sum will have the sum. And watch this. We start off, sum is equal to 0. I becomes 0. As we loop through, the first value gets added to what was there, so now we're at 45.14. I becomes 1. We're now going to add 45.14 here to what's currently there, should become something like 90.28. So 45.14 plus 45.14 is 90.28. That gets reassigned into sum and changes the value. Now we go to 2. We add the next number, and so on and so forth. And eventually that will have the total, and you'll get the average. So how do we declare and initialize arrays? So we saw how we declared an array. If you want to initialize an array, the way you can do it is with curly braces. So in this case, if we declare an array of 5 integers, here we're creating this. We can just initialize the values by putting a curly brace and putting 5 integers separated by commas in the curly braces. If we declared an array of strings, so here we have 3 strings, notice that the curly braces have 3 strings separated by commas. And so the list of array values is a list of initial values for the array elements. Commas must separate the values, and the first value is placed in the first element, so the 0th index. So 13 is in the 0th place for lengths, and Kelly is in the 0th place for names. So here we have an example of initializing 5 colors and declaring the array and initializing all in one line. And then here we have compression ratios, some doubles that are being declared all in one line. So declare and initialize a string array called names to the values Larry, Curly, and Mo. So pause, write down what you think the answer is, and then write down your answer. And hit continue. So in this case, it's going to be a string array, so put string. And it's going to be an array with 3 elements. And we'll put in our initialization statement. So that's how you would initialize that. And then try this. Declare initialize a double array called numbers to these values, 1.1, 2.2, 3.3, and 4.4. And so pause, write down or think about your answer, and then hit continue. So in this case, we're storing doubles, so we'll declare the array as a double. And it's going to be called numbers. We have 4 elements, and to initialize it, we use the curly braces. And that's our array. Now, one of the problems with arrays is you can actually go out of bounds on an array. C++ does not do any type of array boundary checking when the program uses the array. So it is possible to try to index an array off the end. And, sometimes this and the danger is you often won't necessarily realize this, and it can have some bad consequences. So here's an example. So here we have 2 arrays, high and low. Both have 4 elements in them, and we have 2 loops. Notice that the condition is I less than or equal to 4, and since arrays are 0 indexed, this will cause it to go from 0, 1, 2, 3, which are valid elements for indexes for these arrays, but then it goes on to 4, which is 1 beyond the end. And this code just assigns a value into the element just so we can see what happens. And this is what will happen. We start off our first for loop, I becomes 0. And so low at index 0, we assign I plus 5. With 0 plus 5 is 5, so that goes into here. We loop back through, go to the next I. We get 6. Now I is 2. 7. Now our 3 is 3 less than or equal to 4, yes, so we get 8 here. And notice we're already at the end of the array. But then the question is, when I becomes 4, is 4 less than or equal to 4? Yes. So it's going to do one more iteration. And notice what happens. When we assign into low index 4, it goes to the next point in memory, and it's writing in the next array. So that's not good, but it's not too bad, because here, if we go into the next array, we'll immediately go into high index 0, which will overwrite that. So now we're okay again. But as we go through, we get to index 4. And then when we come up here, it's now trying to write at high index 4. Well, there is no high index 4. And so you'll typically get an access violation at this point because it can't access the end. By the way, that 5 disappeared at some point during that. That's just a typo. Okay, so here we have an array with 4 elements, and we have this for loop. Try to identify what's wrong with this loop. So pause, find the mistake, and then we'll discuss it. So the problem is right here, this equal sign right here. If we put that equal sign, then we will go to index 4. And remember, because arrays are 0 index, the valid indices are 0, 1, so 0, 1, 2, and 3. There is nothing at index 4. So if you go less than or equal to 4, this array will overflow. So you've learned vectors before. Vectors allow a program to add elements into a vector without limitation. So the nice thing about vectors is they can grow and shrink in size as the program executes. When you declare an array, it's fixed at that size. So if you know how large something is going to be, then an array makes sense. If it's going to be more dynamic, then a vector makes sense. And so that's the logic. If what you're doing is dynamic, then you would use your vector. Your phone bill program makes sense as an array because you know how many phone bills you're going to have in a year. So at this point, complete the array demo. And that's what we went over. Thank you very much.